Dr. Esther Trufan, and in this video, I'm going to demonstrate the electrolysis of water. And to make this experiment work, we're going to use some electrolytes. For today's experiment, we're going to need some equipment. The first and most important is going to be some kind of source of electricity, and that will be a battery. And for this experiment to work, we're going to need a 9-volt battery. To connect the battery to the rest of the setup, we're going to need some alligator clips. We need 2 of them, one for the positive and one for the negative end of the battery. And then for the setup, we're going to need a stand and an O-ring. Here's the stand, and we're going to attach an O-ring to it. The O-ring has an O shape, and I added a little bit of tubing around it to make sure that the cup that I will place on it does not have too much pressure on it so it doesn't break. It should be relatively steady. Now, into this O-ring, we're going to place a cup that has 2 electrodes on the inside. And for us, that is a plastic cup in which we created 2 holes pressed through 2 pencil leads and then sealed off those holes with some glue. This will go here. And then on top of the 2 electrodes, we're going to place 2 graduated cylinders. We're going to produce a relatively small amount of hydrogen and oxygen today, so we're going to use 2 10-milliliter graduated cylinders, both of which will be useful in measuring the exact volume of each gas that will be produced. To make our electrolyte solution, we're going to need a 400 milliliter beaker in which we're going to measure some sodium sulfate. Then we're going to add some deionized water. And we're also going to add some indicator solution. And for today's experiment, I am going to use butterfly PT, but you can also use a red cabbage indicator or any other acid-base indicator. And finally, to measure out a known amount of the sodium sulfate, we're going to need a scale and potentially a spatula. So let's start first with the measurements. We take our scale, turn it on. And to avoid losses due to transfer, we're going to measure everything into the final container, which in this case will be the beaker. So we turn on the scale, we tare it, and then we add approximately 2 grams of the sodium sulfate. I measured exactly 2.00 grams of sodium sulfate. And with that, I am done with the scale. I can turn it off and set it aside. Next, I am going to add some deionized water to my salt. And I will add approximately 300 milliliters. That will be more than enough water to get all the sodium sulfate to dissolve. That should be enough. And if I have my spatula, I can use this to stir, or I can find a stirring rod and use that to make sure that all the sodium sulfate is fully dissolved. The sodium sulfate is dissolved. I can set my spatula to the side. Next, I am going to add my acid-base indicator. And in the case of butterfly PT, it will turn a vibrant blue. Next, I'm going to take my graduated cylinders, and I am going to fill both of these up to the rim. And if a little bit comes out, it's all right. We can use paper towels to wipe them off. I will come back and fill it in a little bit more in just a little bit. So I'm going to set this to the side. Bring in my setup. And I'm going to add enough of my solution to fully cover both electrodes. And then I'm going to leave some excess just in case I don't succeed on the first try in transferring my graduated cylinders upside down on top of the electrodes without having any air bubbles anywhere. So we're going to take this one. Make sure it's all the way full. And then we do our best to cover it up turn it upside down, lower it below the level of the solution. And we didn't succeed on the first try. So that is why we have excess solution. We can use a little bit more there. And fill this up all the way to the rim. And if we don't succeed on the first try, we try again until we do. And this was a lot better. And we place our graduated cylinder on top of one of the electrodes. Now, if we are lucky, it will work on the first try. And if we're not, we try again. Try again. If we don't get this part right, the rest of the experiment doesn't matter. This was a lot better. And we're going to place our second graduated cylinder on top of the other electrode. And now we clean up our space just a little bit to make sure that this does not interfere with the flow of the electrons. Now that our setup is ready, we take our battery and we can place it right under our setup. Then we take one of our alligator clips, connect it to the negative end of the battery and connect it to electrode on the right. And then we take the other alligator clip, connect it to the other side of the battery and connect it to our left electrode. Once the connections are made, we should see bubbles forming. And if we look at the two graduated cylinders, we can see a lot of gas formation in the graduated cylinder to the right and somewhat less gas formation in the graduated cylinder on the left. We are also seeing a color change. The graduated cylinder on the right is turning a little bit greenish, and the graduated cylinder on the left has solution that is turning slightly pink. We're going to let this go until we have at least 3 or 4 milliliters of gas collected in at least one of the graduated cylinders. And at that point, we come back to the experiment and we look at the results and try to draw some conclusions. It has been approximately 25 minutes or so, and the volume of gas collected in one of our graduated cylinders has exceeded 4 milliliters. So this is a good time for us to stop. I will disconnect my alligator clips from the battery and then set aside my battery. And then I will disconnect my alligator clips from the electrodes carefully so that I don't break them. You may know that pencil lead is notoriously easy to break. And then as I survey my graduated cylinders, I can lift them up just a little bit, but it is very important that we don't lift them out from the solution so much so that the top of the graduated cylinder, or in this case, the bottom, does not break the surface of the solution. If that happens, then all our solution will flow out and then we won't be able to record a volume. So for this experiment, we're going to record the volume of the gas collected in each graduated cylinder, and we're going to record the color of the solution in each graduated cylinder. So let's start with the pink one, because that does not seem to create any more bubbles. And there are lots of them on the surface. So in this case, our volume is going to be an estimation. And it looks like it is 0.83 milliliters. So a very small amount. On the other side, we still have a little bit of gas formation. So we can wait a couple minutes here. And as we lift up our graduated cylinder slightly, we can record the volume. And the volume is 5.11 milliliters. So we have a pink solution with less than 1 milliliter of gas, and we have a yellowish green solution with a little over 5 milliliters of gas formation. Because water is composed of hydrogen and oxygen, one of these two gases is going to be the hydrogen and the other one will be the oxygen. And because we have graphite electrodes, one of those gases is not going to react with the carbon in the electrode, and the other one will. So, for your explanation of this experiment, you may want to consider which of these two gases, oxygen or hydrogen, is more corrosive and more damaging to your electrode. Should you want to continue the experiment longer, you can. Make sure that you record your observations and you keep track of the amount of gas that forms in both graduated cylinders. After you collected your data on the amount of gas that is formed in both graduated cylinders, and you recorded the color associated with each gas formed, there is one last experiment that you can do, and that is the lifting of the graduated cylinders. So you slowly pull them up, and you'll notice that as soon as you break the surface, your solution flows out. There is a small amount of hydrogen and oxygen that is forming, but this is so small, there is no chance of explosion. Still, you may want to avoid any kind of open flames around this experiment. And now, let's mix our solution carefully, because once again, the two electrodes that are in there are going to be quite sensitive, and we don't want to accidentally break them. At this point, I don't recommend reaching into the solution with a spatula or a stirring rod because you can break the electrodes, but give it about 10 minutes and come back to it and record the final color of your solution.